Welcome to another cloud coding video with me, MoSafe. In this tutorial, I will be going through the steps to configure a cloud-native development environment. This video is part of Intelligent Microservices on Kubernetes tutorial, where I demonstrate many cloud-native concepts like container orchestration, DevOps, AI, and event-driven development through a real-world scenario. To check out more details about this tutorial, visit my GitHub repo link in the description. Let's go! I would assume that you have successfully completed the setup of the dev machine and have reviewed the architecture in the solution whiteboarding guide. If you didn't do that yet, check out the setup and solution whiteboarding guides on GitHub link in the description. Now, it is time to start provisioning the actual Azure services that will construct our platform. I will go to the home page of the workshop and then heading down to the prerequisite guide link. Let's get started. First thing to check out is your development environment access to the Azure subscription. I will discuss here two options. First option is about using Azure Cloud Shell. Heading to the Azure portal and clicking on the Cloud Shell icon, you will be greeted with the Cloud Shell, which have already everything we need in terms of tooling. Second option is using Visual Studio Code, which I would strongly recommend. If you don't have it installed yet, you can check the setup guide on how to configure your development machine. Okay, let's head back to the guide. Now I will be getting the Cloud Workshop code. First, make sure you fork a copy of the repository to your GitHub account by clicking the fork button. I would highly recommend doing this before proceeding. In your forked repository, you can proceed with cloning it to your local machine or shell development environment from the clone link. Let me demonstrate quickly how to do this using Azure Cloud Shell and Visual Studio Code. Let's start by the Cloud Shell experience. Let me copy the clone commands. I will maximize it for better view, then simply paste the copied commands. First command will clone the GitHub repo into the Cloud Shell. Next command, I'm switching the active folder to the Intelligent Experiences on Containers. Finally, I'm launching a light version of Visual Studio Code via executing command code dot. This command will open a nice file explorer with a built-in code editor so you can easily edit and execute scripts. For example, scripts for provisioning Azure Prerequisites are in a folder called Scripts under the folder Source. If you open it, you will see the Prerequisites script. Simply clicking on it will open it in the file editor. In this script, I have added ready to be executed commands covering the services provisioning for this lab. Simply by copying and pasting sections of this code into the shell console, you can progress the script execution. Super easy, right? My favorite option though will be using Visual Studio Code. So let's just do that. I will start by creating a folder inside my file system, then through Visual Studio Code, I will clone the repo into that folder. I will open the File Explorer and navigate to the desktop to create a new folder. I will call it IE. That's it. I will now open VS Code to clone the repo. This can be easily done by clicking View, then Command Palette, or pressing Ctrl-Shift-P. By typing git clone and hitting enter, You will be prompted for the repo URL. Switching to GitHub, opening the repo root in a new tab, copying the clone URL, back to Visual Studio Code and paste it. I am prompted to select a folder. I will select the new IE folder I created earlier. Give it a few seconds. VS Code is nice enough to ask if I want to open in a new window, but I will just open in the same window. Now, I have all the repo files locally in my machine. Again, locating the scripts folder under source, Prerequisites script is available and ready to go. Now let's open a new Visual Studio Code terminal, and depending on your operating system, you might notice that by default you will get PowerShell terminal under Windows. I want to choose another default terminal type, and since I installed WSL, I get terminal option for WSL bash. Sweet! I will kill this terminal and create a new one. Now you can see I am in WSL bash terminal running on Ubuntu. Now we are ready to go. I want to show that on GitHub you can go through the steps using the guide. I included a lot of details on why and how for each section with additional information. You can run and execute the scripts by copying and pasting directly from GitHub guide into either Visual Studio Code or Azure Cloud Shell. Alternatively, you can use the sequential commands in the Prerequisites script. My preference would be using a single script that has everything in sequence. I will explain each command on the go. Let's get bashing. Going to the top, first command to be executed is azlogin. Let's just do that. It will open up a browser window prompting me to sign in into my account. I will select my account. Once you are signed in, you can safely close this window and head back to Visual Studio Code. In Azure Cloud Shell, you don't need to log in because you already are in with your Azure account. After a successful login, all the subscriptions under your account will be displayed in JSON format. You need to make sure that you are only selecting the right subscription that you target to create the resources in. I will replace this name with the subscription name that is relevant to me. In my case, subscription is called MCT subscription. Let me try to execute this one. Great. To make sure that the right subscription is selected, I will retrieve my subscription ID and the tenant ID out of my signed-in account. To do that, I will copy all of these commands and paste them at once. Brilliant, clearing the window for a fresh screen. Moving to the next section, which is about setting some cool variables. In order to make sure that this script can be reused by just updating the variables section, I use variables that will control the entire deployment naming and configurations. Let's check each one. I always start by setting a prefix to use across all resources names. In this case, I'm using CAP, which stands for Cloud Analytics Platform, followed by a random number. My resource group name will be the prefix combined with -RG. The selected location in my case is West Europe. Feel free to select other Azure region as you see fit, but make sure your subscription is allowed on that location and has enough resource quota to provision the target resources. Next, I have the primary camera frame storage name. Be careful here. Azure Storage Account only accepts alphanumeric letters, small case only, and globally unique. Now, Cosmos DB account name, service bus namespace, cognitive services account, Azure Container Registry, our virtual network name, Azure Monitor Log Analytics Workspace. I will copy all of these commands and execute them. Remember to visit the workshop prerequisite guide if you need further information. Now it's time to provision the actual resources. I will start by provisioning Azure Resource Group, which will act as a folder that will contain all of our provisioned services. Next is creating Azure Storage Account. I'm creating here a new storage account and a blob container to store our camera frames in. I will copy again all of these commands and execute them. Executing this part as well. Now my storage account is done. I want to highlight here that some commands would print out connection strings and/or secrets. Please take note of them because we will need them later when we start connecting the platform microservices to these deployments. Let's see what's next. Cosmos DB, which is a global scale NoSQL database. This is the connection string that I will use for the Cosmos DB. Coming up is the service bus. Azure Service Bus is defined by a namespace. A namespace represents a pub/sub messages hub where messages are published to a topic that is consumed by subscribers. I will provision multiple topics and subscriptions where each microservice will subscribe to a topic. You can consider each topic as a different pub/sub queue. For example, I have here a cognitive request topic and the associated subscription. I continue to pair a total of 4 topics with 4 subscriptions, 1 pair for each microservice. Enough talk. Let me copy the entire service bus section and execute it in one go. What else? Here we are creating the cognitive services account and retrieving the cognitive key. You know the drill. Next, I have Azure Container Registry, which is a private enterprise images registry where all microservices images will be tagged and pushed by Azure DevOps pipelines. I will need also an account to access this container registry from Azure DevOps. So here I'm creating a service principal to be used to push our DevOps built images. Clearing the screen for a better view. This service principal needs permission to push images to our registry and maybe pull also. Let's grant it. Virtual network is next. Networks planning in general usually requires a careful design, especially in interconnected enterprise deployments to avoid IPs overlapping with other connected networks, whether on Azure or on-premise. Here, I'm just creating a simple address ranges for the platform to use. Setting the network parameters now. With that done, I will now execute the actual network creation and all the needed subnets. Let's see what is next. Next is our telemetry resources to keep an eye on how the system is performing. Log Analytics will be used to monitor the Azure Kubernetes service infrastructure, and Application Insights will be used to monitor the performance of each individual microservice. Let's execute it. And we are done. I'm almost done with the prerequisites provisioning. One final prerequisite is the Kubernetes service principal. Azure Kubernetes Service execute multiple Azure resources modifications on your behalf while operating the cluster. AKS uses a service principal, or in some cases a managed identity, to authenticate to Azure APIs. For example, to scale the cluster up and down, AKS uses this identity to maintain the infrastructure based on your instructions. Here I'm creating an AKS service principal and just granting it enough permissions to allow it to access the virtual network and Azure Container Registry. Executing this now. Brilliant! Now we are done. All the prerequisites are now provisioned. But before you close this active terminal session with all of the precious variable values, secrets, and connection strings, I want to highlight one last point about saving all values to a file called crowd-analytics. Running these commands will make sure that you can later retrieve all variable values. To reload the saved variables at a later time, you can simply execute the command source crowd-analytics. Let me open portal.azure.com and have a peek on the project resource group. You should see something like this. You might have a different random number, but these are all the resources I just created. That's a wrap for now. Thank you for sticking around, and if you found this content useful, please consider giving it a thumbs up. I'll try to publish new content when I have story to tell, so you might consider subscribing and clicking the bell notification icon so you will not miss future videos. Cheers!